Hey YouTube, what's up? Greg here from GregsTutoringNYC. How y'all doing? How y'all doing? How are you all doing? So, we're doing the show your work part of the hardest math problems. I already spent months doing multiple choice sections. So I'm sourcing these from the New York State exams, and they're the problems that most kids got wrong. It turns out in the show your work section that most kids got most of the questions wrong. So I'm going back to past exams and doing the whole show your work sections that they released, at least to the public. And that's the premise that we're taking here. And however, I'm trying to avoid doing this as test prep. I'm really trying to touch on the concepts and topics that are, quote, grade level, quote, age level. There can be disputed where a certain topic should fall, but at least in New York State, which follows Common Core, certain topics are in certain grades, like multiplication up to 100 is grade 3, etc., etc., etc. It doesn't really kind of matter where you fall. There's still a general flow that kind of happens that, a kindergarten is not going to necessarily be doing calculus, right? So this follows that same kind of general flow. So if you're not in New York and you're not taking a New York State test and you're even in another country that's not even the United States, these are still appropriate. Kind of find the level where you are. You could be an accelerated grade 5er and maybe need to wait until I get to the grade 7 stuff. That's it. I already did the grade 7 multiple choice examples. And this is just an ongoing series that I've been doing for about a year, in addition to all the other videos I do mainly about math and English. So check out the site. On that note, please hit subscribe. Please like this video. It's a lot of work, and it gives me encouragement to know you guys are getting something out of this. I mainly do videos on high school admissions, but I think this is part of the predecessor to that, if you will, because if you can't get the fundamentals down right, you're kind of messed up. There's a lot of really horrible middle schools. There's you may have controversy in your family for one reason or another, etc., etc. So these are all free. I do tutoring. You can contact me below at GregsTutoringNYC@gmail.com for that. But we're going to jump in here. I try to make these about an hour. If they're going to go longer, I'll split it up into 2 pieces. There's 1 or 2 questions on this series, this particular exam, that is a little interesting, so I might spin those out. I'm not sure whether to do them and then explore them further on a video by themselves, or to just pull them out and actually explore them at depth. As we're going through this live, I'm going to figure that out. This is about 10 questions, so it's about an hour, 6 problems a question, depending on where I go. Some are simpler than the others, some are harder than the others. Remember, sometimes the problem with getting a math question wrong is not necessarily mathematical, so we explore those aspects too. In the real world, if you have to solve a problem, you need to solve a problem, so you need to be astute, awake, giving it your attention, not making silly errors, reading the question properly, stuff like that. You can't go to your boss and say, like, "Oh, I thought you were talking about something else." So it's about your undivided attention to something and your rigor and things like that. So we're exploring numeracy, fluidity, mastery of the math, no hesitation math, things like that. Okay, guys? All right, so let's jump in. Okay, let me just make sure we're still good here. Yes, we seem to be. All right, because there's nothing worse than doing these than doing them with a broken stream or something like that. All right, so let me see if I can get this going. Okay, yeah, my tablet's good. So we have 5 numbers. They look like they're decimals. And this is already leaping out at me because I like to look at the illustration first. To me, this is an illustration. So obviously they want me to rank these in numerical order. And let's go back to the words now. Rearrange the numbers below so that they are listed in numerical order from least to greatest. So when we have a decimal number, we have the whole number part, dot the decimal part. And the whole number part can be multiple digits, and the decimal part can be multiple digits. Okay? So what we want to do is kind of split that in half, and we're going to compare the whole numbers first. Okay? So the smallest ones is this 32.94 and this 32.102. Okay? So there are our first two numbers. The question is, which goes first? Okay? So normally, this here is 94, if we compare just the decimal part, and this is 102. So normally 94 is less than 102. The problem is we're not comparing 94 with 102. The way the decimals goes, if you have a decimal, you have tenths, hundredths, and then thousandths, right? Thousandths. So 102 is 102 thousandths, right? We use the last thing here. But 94 is 94 hundredths. So we can't just off the bat compare a hundredths to a thousandths. So one way to do that is to put a 0 here. So now you can see that we're comparing 102 to 940. So we have to pad out with those trailing zeros to make sure, because we're not just focused on the 94. To get it into thousandths column, we have to get them both oriented with the same place value, right? This is the place value. So that's what this is testing as well, in addition to decimal numbers. All right? So it turns out that 32.102 is smaller than 32.94 because there's an implicit 0 right after that, okay? So then we're left with 33 is the next one here. There's only one 33, so it can go there. But we're comparing whole numbers at this point. And now we're going to compare the next level up, which is the 34s. So there's a 34 there and a 34 there. And we have the same situation. We're going to compare the 039, not 39, but 039 to 198. And we're going to get 34. Okay, so in this case, this is 39 thousandths, right? We could write it as 39 over 1,000. And this is 198 over 1,000. So in that case, clearly the 39 one wins. And we have to write down the 0. We can't leave it out, otherwise it's 39 hundredths. Okay? And then finally 34.196. Okay? So be careful with that. Some students answer this by ignoring the decimal part completely. And they pick like 336 is the first one. And then 3294 is the next one. And then, let's see, they would get that. They would get that. Then they would do 32.102 as if the decimal point was a comma. And then 34.039 and then 34.198. That's wrong. That's not what you're doing. You have to compare the whole number of parts first. And then if they're the same, then distinguish between the decimal parts, noting that the 0 in the beginning brings it to the right place value, and we need to sometimes add a 0 at the end. All right? And we can see the whole number, 32, 32, 33, 34, 34. Comparing the decimal point, 102 versus 940. Obviously, the 102 wins. 33.6 is by itself. And then we have 039 versus 196, right? And just to be clear on these two, right? This would have been 32 and 102 over 1,000 as originally written, okay? This one as originally written would have been a 32 and 94 over 100. So to compare the two of these, we multiply this one, the right-hand side one, by 10. 10 on the top, 10 at the bottom. So now we can see we're going to compare 102 to to the 940 because we were able to get the common denominator there. All right? So that's what's going on there, people. So don't remove the decimal and make believe it's a comma. Don't look at the number as a whole. You have to look at the whole number part, the integer part, and then the decimal part. Okay, theoretically, there's a way to make these into fractions, every single one. You didn't really need to go there, but if it helps you, you can do that as well. Okay, so this is mainly about place value and about decimals. It's indirectly also about fractions as well. And the key is making sure that you know this 0 over here. That was really the main crunch one, this one right here. Okay, that needs to be there. Okay. So finally, now that we have the right order, it says the number 3301 is added to the list so that the new list is still in numerical order. Okay? So it wants us to take this 3301 and plug it in up here. Okay? Between which two numbers should it be placed? So this is critical right here. Because otherwise, we could say any two numbers, right? As long as 3301 is between them. Like we could have picked the very least number here and the very greatest number of this list. And 3301 would have still been between them. But it says the new list must still be in numerical order. All right? So what we need to do is compare it. If I said this was choice A, this was choice B, this was choice C, this was choice D, this was choice E, and this was choice F, right? My other choices got kind of lost in there. But so 3301, it's obviously greater than A and B, right? So 3301 is greater than this. Let me change the color of the pen again, just so we can kind of get lines in the sand. Let's make it purple. So 33 is greater than 32, so we know it's at least between these two. The next number is still 32, so we're there. Okay, it might be here. Okay, the next number is 33.6. So, and then over here, we're over here. So we know it doesn't go this far. So it's most likely there. So let's see if it's here or here. Okay, so 33.01, whoops, compares to 33.6. So remember, this is 1/100th. This is 6/10, right? So if we had 1 over 100 compared to 6 over 10, we need to get a common denominator. That becomes 60/100ths. So obviously this is greater. Okay, so it would go right there. Okay, and to be clear, we're talking about 32.94 and 33.6. Okay. And we could have done that. We could have added the extra 0 right over here to try to emphasize that as well. All right, so this is really about place value, and it kind of gave you two things here. This is a 2-point question. It's kind of unfair because if you didn't get the original answer right, this right here, if you got that wrong, then you can't get the second part right. You're messed up. On the same note, in a way, they threw a bone by giving this second answer choice here, because that's a kind of a shot for you to realize, oh, I may have messed up the top, and to go back and kind of refix it. All right, so there's that. So the concept here is really place value, and it's an interesting way to kind of do it. They could have simply just given two numbers and worked from there, but they made it a little involved, which is cool. You want to be tested. So in a way, there was 1, 2, 3, 4, 5. There's about 6 or 7 comparisons that you really kind of had to get there to get that right. Okay. Okay, this is one of the ones that I was talking about earlier that gets a little more involved. This is what I'm going to do. I'm going to skip it for now. And if there's enough time in this video, I'm going to come back to it. If not, I'm going to split off into a second one. So I like to keep these under an hour if I possibly can. So that was 47. 48 has no illustration. A library has 6,400 music CDs stored on 26 shelves. So it has about 6,000 CDs on about 30 shelves. Okay, I would stop right there, right then, and do 6,000 divided by 30, right? Which means each shelf has about 200 CDs on it. Okay? So first of all, what I did was just try to get a scale of the problem. Don't know what the question is eventually, but I'm kind of doing a back of the envelope estimate to try to figure out what the answer might eventually be. This may have nothing to do with the question, but it's something you need to kind of get yourself used to. And I can do this in my head in 2 seconds it took, right? It took me a minute to explain it, but this is what you need to have going on in the back of your minds to be mathematically astute and things like that. So library has 6,400 CDs on 26 shelves. If the same number of CDs were stored on each shelf, how many CDs were stored on each shelf? Okay, so if the same number of CDs were stored on each shelf, how many were there is basically what they're asking. So that's weird, that repetition of that phrase, but that's what they're doing. So we kind of already know that the answer is going to be around 200. Okay, so that means what I did was, the second thing this estimate does for me is that if I come down here, what I really did was 30 into 6,000. Right? I did it in my head really as 6,000 over 30 and got to 20, but I can do it this way. 30 goes into 60 twice and then the 2 zeros, right? So that's my model. That's my model. So that's all I have to do. So I'm going to have the total 6422 divided into divided by 26. All right? And I can double check my model by doing the reverse. 200 times 30, right? 200 times 30 equals 6,000. Okay, so that works. My estimate seemed reasonable, and I could work back and get the original number, right? So here we're going to do that same thing. So this now deals with double-digit division, multi-digit division actually. 26 goes into 54. You have to kind of guess around there. You can do little scratch pad things on the side here. 26 times 5 times 4 times 3. I can see that if it was 20 times 3, that's already 60. So it would have to be 2. 26 times 2 is doubling it, right? And you would get 52, I believe, right? So it goes in there twice, right? 52, and you get 12 left over, if I'm doing this correctly. Okay, and that's the problem with doing some of this live. Okay, if times 2 was 52, that means times 4 is 104. Okay, the question is times 4 is 104. Can I fit another 26 in there, right? Which would be times 5. That would give me 130. That's too high. So this is 4. And if you can't do what I just did here, replay the video and see what I just did. If not, you can do 26 times 4. Right? You make a guess. Your guess could have been 6 or 5. Eventually, you're going to get the 4. 6 times 4 is 24. 2. 4 times 2 is 8. You get 104 there, right? So it's the same number I got a minute ago right here. 52 twice is 104. So we get the 4. We got 104, right? What are we going to get as the remainder? Is that 18? Uh, 122 from 104. Yeah, it's 18. We're going to get 182. And then we have to make a guess again. I don't know the answer, so we can guess around. 26 times 7 gives 2. We're trying to strive for that 2. So that's one way to guess your multiplication, because 6 times 7 is 42. 6 times 6 is 36, unless there was a remainder. But let's try to shoot for the one where it actually has the same unit place digit on the 182. So we get 6 times 7 is 42, carry the 4. 7 times 2 is 14, plus the 4 is 182, so we get exactly, okay? That's what we get exactly there, is 247. So that would be the answer. 247 is the answer. And if we go down to here, we get whatever CD is, right? So we're making sure we're trying to look for the same number. We're going to go back to the problem, see is there another part of it that we missed? Is there a step 2, another step? Nope, this was just straightforward like that. And then what we're going to do is go on the side and do 267 times 26, okay? And double check to see if it actually gives us back 6422. And if it does, then your answer, 247, then your answer 247 is correct. All right, so always do that check. And it's a way to make sure that you're getting it correct. All right, because if you made a mistake in the division, it's going to kick out here, or should cook out there. It's not a guarantee, but you're up in the ante to make sure that that is what you're doing there. This one is really just about figuring out about equal parts. You know, we talked a lot of that about in grade 3 and grade 4. There's 27 items per shelf. So how many equal parts of 26 do we have? Which also means it's kind of indirectly tied into multiples. My phone is noisy today, so it's about multiples as well. Obviously, it's about division. Obviously, about multiple digit division and multiple digit multiplication. So these are all basic things since grade 3 that you guys should be striving towards. Okay. And things like that. So the answer was 247. Okay. Some of you may get numbers close to this. You may end up with, say, 245 or 248 or 246. Remember, your double check is the way to make sure that you didn't do a slight error in your division. Okay. And you might say, well, hey, Greg, you said the estimate was 200. Yes, that's what an estimate it is. An estimate doesn't get really super close. It just gets ballpark close. You might say 47 is pretty far off from 200. Yeah, that's how estimation works. So there's a little room of error, a little delta there that gets involved that you still need to be concerned about. So I'm concerned about my estimate being like 5, right? That's really way off. And I'm concerned about my estimate being like 5,000. That's super way off, right? So what we're trying to do is get ballpark estimates, and there's rounding errors, right? That's the problem with estimates. They're only an estimate. They're ballpark numbers. Okay, so that's 48. Let me see what's going on there. Give me 1 second. All right, I'm getting lots of calls and emails through this. I tried to time this when that wouldn't necessarily be the case, but there you go. Okay, so 49 is 2 parts. Okay. Describe the relationship between n and 4 that will make the value of the expression, this here, greater than 7. Okay, so what you need to do is kind of look at it a little bit and say, what value of n would make this greater than 7? Well, we have 7 times something needs to be greater than 7. So it seems to me that this thing needs to be greater than 1, right? Question mark needs to be greater than 1, right? Because if it was half, then I would get 7 times a half is 3.5. And if it was negative, like -1, I would get -7 is greater than 7. No, that's not true either. But if it was like 2, then I would get 14 is greater than that. So now there's a second part to this, which is our question mark is n over 4. So for this to be greater than 1, it seems to me n must be greater than 4. All right? So in other words, if n is 4, then we get 4 over 4, and we get 1 is greater than no. So it means it needs to be greater than 4, because if this is 2, we would get back to, say, half, and I just gave those examples over here about that. So this is kind of a two-step thing. One is you have to realize 7 times something greater than 1 is going to give you a result greater than 7. And then when you realize that this part here has to be greater than 1, now we're looking at the n over 4 is greater than 1, right? And we can go through the same scenarios. If n was 8, right, we would get 8 over 4, that's 2. So 2 is greater than 1, that matches that. And then 7 times 2 is 14, that's greater than 7 if we come back over here. If we go back to the negative number again, if n was, say, minus 8, then minus 8 over 4 is minus 2. That fails this test here. But if we just keep using it, 7 times minus 2 is minus 14 over here, and that fails this, right? So that's no good. And then if we use a fraction, if n was a quarter, right? A quarter divided by 4, right? And this is the same as anything as the number over itself. We would get a quarter times 1 over 4. And that's a 16th. So 7 times the 16th, that's not greater than that. So that's what we have it. So we did our little experiments to try to understand the expression. And now they want you to describe the relationship between n and 4. Okay? So you have to get into that a number over itself is 1. And that that's one identity. And the other identity is something times 1 is itself. So those two things combined together, it has to be greater than it, right? Because it didn't say equal to it. So you need to put those words down describing that, okay? And if you don't mention all that, and you can get that down in a sentence, it's not probably the easiest sentence in the world to do, but what you want to mention is those two identities in your own words somehow, and the fact that you see that n here must be greater than the 4 to make that greater than 1. And then once that's greater than 1, then this, which is this, right, then it has to be greater than 7 because this over here is 7, right? And then the second one is kind of similar. It's again asking for a description. So describe the relationship between A and B that will make the value of this expression equal to 1. Well, it seems to me you need to know the identity again. That's 7 times 1 is equal to 7. So that's the identity, and therefore we want A over B to be 1, right? So that means it must be the same number. Okay? A and B, the relationship between A and B is they're the same number. So that will work in all examples except for 1. So if A is positive, let's say A is 5, if A is 5 and B is 5, then we have 5 over 5 and 7 times, which is 1, and 7 times 1 is 1. If A is minus 5 and B is minus 5, we have minus 5 over minus 5, that's still 1, okay? And 7 times 1 is still 7. If A was 1 over 4, like we did up here, right, we would have 1 over 4 divided by 1 over 4. That's still this is still a number over itself. And we can actually show that 1 over 4 divided by 1 over 4. Well, that's multiplication. Division by a fraction is the same as multiplication of its reciprocal, and this becomes 4 over 4 when we multiply it out. Right? We multiply the numerators, we multiply the denominators. So it all works out, and everybody lives happily ever after. There is one scenario where it doesn't work, which is that if A and B is 0, 0 over 0 is undefined because we can't divide by 0. All right? So that's the one scenario. And I don't think they were really worried about this at this grade level. I can't recall if students know that fact at this grade level. Yeah, you probably do. So this is about this is about algebra. This is about inequalities and kind of equalities at the same time. It's about fractions, it's about magnitude, and this is about logically relating what these things are about. They're also under a concept called inequality, which you guys really don't learn much more about later. But we could have solved, say, up here, 7 times n divided by 4 is greater than 7, right? That was an n there. Okay, so this 7 times n over 4 is the same as 7/4, or 7 times n over 4, right, is greater than 7. And we could have multiplied this by its reciprocal, 4/7, and got rid of it there. Multiplied this by 4/7. That kicks out, and all we're left with is n greater than 4. So I just solved this algebraically for anybody who kind of knows what that is, and that's what our inequality is. And if you notice, that's what we concluded up here earlier, multiple times. Okay, and we could have done that same thing down here, working with that same kind of notion. All right, because if we had 7 times a over b is equal to 7, right? If we divide both sides by 7, this goes away and this becomes 1. So what we have is a over b is equal to 1. Whoops. So for those of you who know how to do this algebraically, there you go. You could have solved it that way as well, even though that's beyond what's normally taught in grade 5. And I kind of like this exam. Like I said, there was 2 harder examples. I skipped the one before. I'm probably going to skip another one. You know, I think they really push some of the concepts here, which is really what this should be about. Okay, and I like that it was written differently than you might normally get. It's kind of causing you to think it through and really rationalize why. And it deals in later grades in high school. You're going to have to start showing proofs and so on. This kind of ties into that at a more naive level, but still it's there. All right, so I like this exam so far. And let me just make sure I'm still going and what my time is. So we're at the half an hour mark. And by the way, for those of you catching this on the replay, you can pause the video and you know, try to guess the answer yourself and then see what I come up with. So we have an illustration. I like to look at the illustrations first. It's distance walked, I guess, of Rosalva and Jake. I noticed in all the examples so far that I covered in the Show Your Work series that there was never any unit conversions. And maybe there isn't here, but I'm noticing this is kilometers and this is meters. Okay? And I often say that I like to add stuff up, and I'm noticing that there's a total here. So it's probably asking me to make that total. I'm not going to do it, and here's why. I don't like these numbers. If it was like 1, 2, 3, 4, I could just fastly do that in my head, or if it was lined up. Certainly this column here is lined up, right? But I'm still not even going to do it because I don't want to add 1977 and 1450 and 1590 if it's not going to ask me to do it, right? So in a lot of the very simpler ones, I actually went and did it just to kind of show you guys, but I always had the caveat that I was really showing you where you should eventually go on a lot of the questions. Not that you should necessarily spend time actually doing that, because the problem may not ask you to do it, so why do it if it doesn't ask you? I'm just trying to give you the insight that might be where eventually it's going to. All right. And now we have 4 days: Monday, Tuesday, Wednesday, Thursday. I don't see a Friday here or anything here. So this is apparently distance walked on specific days. Is it going to ask us to maybe make that into a weekly thing or something? I don't know. So with that, I'm speculating, and with that, let's look at the words. Rosalva and Jake walked a certain distance each day. Cool. So that's what it says. They recorded the distances in the table shown below. So it says each day, but it's only talking about 4 so far. What is the difference? So this is a keyword. This means subtraction normally. So let's see if that is what is going on here. Between Rosalva and Jake's total distances walked over the 4 days. So yes, it did require me to add these up and basically subtract the 2 totals. Okay, but we have kilos here and we have regular meters there. So we need to do unit conversion. We can do it now or later. Both ways work. Okay, so let's try to add this up. We have 7 plus 4, and I did this already on paper because I don't want to make a mistake. I do have dyslexia, and I try to compensate for that, especially when I'm talking live. But I want to also make sure that I'm using the right numbers when something is involved like this. So I could see that 1450 is a completely different number. Usually involving the digits that are there or some digit on the page. Like my mind drags the 1.5 into here sometimes. So, and that's why you often see me double checking stuff. So it's just kind of a subtle hint for anybody who has dyslexia, dysgraphia, and all the other kind of dys stuff. All right, so 0, 0, 4, and 7, I get 1. Carry my 1. Okay, you get 9 and 1 is 10, plus 5 is 15, plus 7 is 22. Carry my 2. 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 plus 9 is 22. And I got 2, 4, 6. 6, 2, 2, 1. Was that correct? Yes, that's correct. Okay. And what I don't like about what they did with this thing here is they didn't line them up. So we're going to kind of have to do that over here. 1.5. Remember, we just can't say 9 plus 4 is 3 here. Carry the 1, right? Oh wait, actually they are lined up. Let me get rid of this for a second. They're lined up because, as I was saying earlier on the other problem, that 69 is good, the 0.04. There's really a 0 here. And there's a 0 there. Okay, so we're going to have 0, 9, 4, 0. It gives us 3, because that's 13. Carry the 1. 6 plus 6 is 12, 13. The dot goes down. Carry the 1. We get 2, 3, 4, 5.33. Is that correct as well? Yes, it is. Okay, so now the problem is we have kilometers versus meters. All right, so we need to know which way goes which. So we can convert this by dividing by 1,000, right? So you have to know how many kilometers is a meter. Or a meter is how many kilometers, right? So 1 meter, right, is equal to what? Or 1,000 meters is equal to 1 kilometer. All right? Let me write that better. So that means we can either convert this, the 6.221, right, into, we can divide it by 1,000 and get 6.221, or we can multiply the 5.33 by 1,000, so by 10, 100, 1,000. So it seems to me it's easier just to go to 6.221 over 5.330. And by the way, sometimes the answer can help us decide. So they want, they want the answer in meters. So we made the right choice because if they want it in kilometers, we could still do this and then convert it to kilometers, but this wasn't too bad. That's a 3. So 1, now we're just subtracting them because it says the difference. So 1 minus 0 is 1. 3 minus from 2, we can't do it, so we're going to borrow. That's 9. We're going to borrow again. What did we get there? 8. 891, is that the answer? Yes, it is. Okay, so the answer is 891. Okay, I could have converted each of these here. In other words, I could have made this 1,500, this 690, this 1040, and this 2100. I could have done that and added them up and still got the 5,330, right? So the key was to notice that there was a unit conversion, and the question is when to have done it, okay? So this is the first one we've run into like that. So maybe they're going to start adding these as the years goes by and doing this chronologically, as well as we get into more further questions in other years. But as I did all the problems in the past, I always said, oh, feet matched, oh, yards matched, oh, there's no unit conversion. So this is always a check you have to do. Don't just let it leap out either that one says kilos and the other says no kilos, right? It's always something that needs to be done. And there are ways to memorize these formulas here about doing the unit conversions. There's acronyms that you could use. There's the what? KHD. Depends on what the unit itself, right? And then decimal, centimeters, milli, right? This is kilo, hecta, deca, right? So there's different acronyms to kind of remember those things as well. I'm not going to go into that here. That's one way to do it. One way is to just memorize the formulas. I like to memorize actually what a meter is equal to, right? 1 meter is normally 100 centimeters. I use that often, or 1,000 millimeters, okay? And I like to base things off of those too. And then I know a kilo is not a milli, so even though they both involve 1,000. Anybody with problems like this, hit me up. If you need tutoring or whatever, hey, I'm your guy, right? So this is about unit conversions. It's about decimal addition and things like that as well. All right. All right. So that's really what was going on. It's also about place value as well. That's really the concept going on there. Okay. This was the one. I think I'm going to skip this, and we'll come back to this because there's a lot of variability to this in producing this answer correctly. There's a straight up answer, and there's some more deep involved stuff I want to get into if we can. Like over answer the question, if you will. Okay, 52. Andy has a collection of movie DVDs. In Andy's collection, 3/5 of the DVDs are action movies, and 1/4 of the DVDs are comedy. Okay? Andy said that 4/9, so we have this, 4/9 is action or comedy. Okay, is that true? Cynthia said that Andy made an error. Explain whether Andy is correct or incorrect and why. And I guess implicitly they allow you to talk about Cynthia in there. So this means we need to use words to explain whether he's correct or not. And we need to base it on mathematical facts. So what we need to do is go back into this and kind of look at it and try to sort of make sense of what they're asking us to do. So Andy has a collection of movie DVDs, right? Cool. And Andy's collection, 3/5 are action and 1/4 are comedy. He says that 4/9 of his total collection is action or comedy, right? So this implies that 3/5 plus 1/4 is equal to 4/9. So the question is it? Well, we can see once we wrote it out like this, that he's adding the numerators and getting that. He's also adding the denominators and getting that. So we all know that doesn't really work. There might be a weird scenario, it's called a pathological case, where that actually ends up being true. But for here, that's not how we do fraction addition. So this is a fraction addition problem. What we need to do is get the least common denominator, right? The least common denominator. And I'm not going to go into how to do that. I actually have other videos explaining that. I would have to find them. Anybody who wants to look for those, you can definitely go on my channel. Of course, you're all subscribed, right? And you all like this video. You're always going to find those. So what we need to do is get a common denominator. It's 20 in this example. So let me line these up. 3/5 plus 1/4. So we need to get 20ths. is what we need to do. So 5 times 4 is 20. So what I do with the denominator, I have to do the numerator. So I get 3 times 4 are 12, right? Just double check that. Divide by 4 is 3, divide by 4 is 5. And 1/4, to get to 20, we need to multiply by 5. So 5 times 4 is 20, and 1 times 5 is 5. Okay? And that gives us 17/20, right? And by the way, yes, when I'm doing these things, I actually write where you, over the way you're supposed to put your answer. In your case, you're down here in the show your work. So I don't want to scroll back and forth and remove the question off the screen. Okay? So Andy says that 4/9 of his collection is that. So the question is, if we compare 17/20 to 4/9, is that equal? No, there's no way. One way to double check that is to do the cross product. 20 times 4 is 80, right? And 9 times 17, you can go on the side and do that. 3, 6, that's 153. So 17/20 is greater than 4/9. And it's definitely not... Wait, I got another sneeze coming. It's definitely not equal to it. So that would be your explanation. And you could go into how to get the correct answer, and also what Andy did incorrectly to get 4/9. He added the numerators and he added the denominators. And that's not the way to solve a question like this one, right? And because of this or here, let me change the pen for a second. And I'm going to wild guess here, but I've seen kids do stuff like this before. Because of this or here, some kids say the answer is 3/5 or 1/4, right? But it's this collection. Both of these are in the collection, not just one or the other. So to say one or the other of these is not correct. Okay, you have to actually add them and try to make sense out of them. All right. So this is about fractions. This is about unequal parts, if we're going to get into kind of stuff like that. It's about knowing how to do the operations, the fraction addition in particular, and also about the least common denominator. Okay, and that's kind of where we're going there. Okay, and then they say, there's a second question here. That's the first question up here. There's a second question here. What fraction is not the comedy? 17/20 is not the answer, right? The 17/20 was action or comedy. What about the remainder? So that would give us 1 minus 17/20. And that would equal to 3/20, right? Because 1 is the same as 20/20. So 20/20 minus 17/20 is 3/20. All right, so there you go. And just to be clear, some kids, so 17/20 is no good, 17 is no good, 3 is no good. It has to be the whole fraction. 17, 3 out of 20. All right, so be careful. Okay, let's see, we're at 48 minutes. I was not originally going to skip this question, but to keep this in an hour, I'm actually going to skip 53 as well, because that actually involves multiple parts. It's not so much hard, but that there's multiple steps, and I want to keep this under an hour for now. This is also involved. 54 is involved. That was one of the original ones I was going to skip. And 55 is also involved. So this is what I think I'm going to do. I'm going to end this now and maybe even make this into 3 parts because there's more involved questions than I thought. All right, guys. Hopefully you all enjoying this. I hope you have a great day. Please hit me up an email if you have any further questions. Again, if you're catching this on the replay, this is the end. But generally speaking, you can pause my videos, replay them. And guess what? You need to subscribe to this channel. All right? There's a lot more of this coming. Once I finish grade 5, I'm still going to do grade 6, grade 7, grade 8. I'm going to do more SHSAT videos. I'm going to probably even start doing reading stuff. And what I might do, it's very hard to do, I might start doing these for the ELA questions. Yeah. All right, guys? Have a great day. Bye. Peace out.